So, hey, Bob. And then 75, 1 through 10. So, talk to me. What did you see on page 39 and 40 that I could help you with? Page 39 and 40, what can I help you with? 16, you got it.
And 22.
16 and 22, cool. Number 16 is the first one. All right, 15x to the fifth minus 10x to the third. Okay, so again, let's do our simple version, because our simple version can get us the right answer, though it might take a little bit longer to do. We still get the right, yeah. Thank you. 5 and 3. Appreciate you. There we go. All right. So what times what gives me 15, and I don't worry about 1 times 15. What else works?
5 and 3.
5 times 3. Thank you. And then x to the fifth is this. Is that okay so far?
Yes.
So then let's break down the 10. So I have minus. I don't care about 1 times 10. What other things, 2 things can I multiply together to give me 10? 2 and 5. Very good. And then I have 3 of these x's. Okay. So let's highlight here. So I have a 5 in common on both. Agree?
Mm-hmm.
And then I have 1, 2, 3 and 1, 2, 3 x's between the two. Okay, there's nothing else in common between those two terms. Do you agree?
Yes.
So out in front, I'm going to bring a 5x, and then inside I'm left with 3xx. Okay, did not interfere. And then minus 2. Now let's clean that up a little bit. What's 5xx? 5x to the third, thank you. And then what is 3xx? 3x squared minus 2. Friends, it's factored. Okay. So 16. What was the other one, Jack, you said?
22.
22. Oh my gosh, look at 22. Can I move off number 16?
Yeah.
We're good? All right, number 22. We have x to the fourth, y to the third, z to the fifth, plus x squared, y to the fifth, z to the third. Okay, does that look right?
Mm-hmm.
All right, again, we're just going to make our simplest. Okay, I have 1, 2, 3, 4. I have 1, 2, 3. And then I have 1, 2, 3, 4, 5. Those are z's, right? And then let's take care of this part. I got xx because I have x squared. How many y's do I have then?
5.
5. 1, 2, 3, 4, 5. How many z's do I have?
That was only 4 Y's.
1, 2, 3, 4, 5. I have 5.
Oh, I didn't see the other one.
I'll get out of the way. And how many z's?
Like 12.
Well, let's use a little bit more critical thinking than that. I got 3 of them, right? Z to the third. All right. So sometimes when things are marked up like this, I go single by single. So I have an x, I have an x. I have an x, then I have an x. Are there any more x's I can factor out between the two?
No.
No. So now I'm going to go to the y. So I have a y, 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 I have a y. Is there any more y's?
No.
Nope. Then I have a z, a z, a z, a z, and a z, and a z. Right? So everything's highlighted that's in common between the two sets of terms. All right. So again, we're making it simple. So let's see. I could factor an xx out, a y out, and a z. Thank you very little. Gotcha. And a z. And so if I factor that out, how many x's do I have left on this first one? And how many z's do I have left on the first
I
one?
think there's 2 Y's.
What?
I have y to the third and y to the fifth. Wouldn't I have 3 of them? Okay.
Bigger.
All right, so then I have x, x, z, z, plus y, y. I guess I could bring my parenthesis in a little closer. All right, clean it up. Make it look nicer. X is the same thing as what? Not 2x. X squared. Y is the same thing as what? Y to the third. And z is the same thing as? Z to the third. Cool. And then inside I have xx, which is x to the second, zz, which is z to the second, and yy, which is y to the second. So we have just cleaned that problem up pretty nicely. Agree? And again, some people are like, dude, Sarah, I have to show how much work. Hey, if you get the answer right, yes. If you get the answer wrong, start showing that much work. The hard thing is, I can't persuade you of how much work really to show and not to show. But if I can see a thought process is going to get you some points. If you went from the original to the blue and your blue is wrong, you missed 3 points. Because I don't see a thought process. Okay, if you go from the original to the blue and the blue's right, you get all 3 points. Okay, that's the hard thing about when I'm grading it too. It's like, show me some work. Oh, I was doing it in my head. Well, I can't grade your head. I'm sorry. I'm kind of sort of okay in a way as a teacher, but I can't grade what's in your head. It's just nature. What else was on any of that page, or what was the other page? 18 you want to see as well? You got it. Number 18, I have negative 4x to the fourth plus 12x to the third minus 8. Okay, let's break this down like we've been doing. Make sure we keep signs available. So I have negative. How do I break 4 down? 2 times 2, good. And then x to the fourth is how many x's? Okay. Now let's break 12 down. 12 is what times what? 3 times 4, and 4 is what? And 4 is 2 times 2. And then x. Cool. Then minus 8 breaks down to what?
2 times 4.
And so 2 times 4, and 4 breaks down to 2 times 2. Sweet. All right. Let's see what we can do here. Let's highlight. I have a 2, a 2, and a 2. I'm feeling pretty good about this so far. I have another 2, I have another 2, and I have another 2. Is there anything else? Is there anything else between the 3 terms I have up there that I have in common between all 3? Have I factored out everything? Does the last one have any x's? Are there any more 2's I can factor out among all 3 terms? Can I factor a 3 out of all 3 terms? Doesn't look like it. It's not there. Okay? All right. Let's see. So I have 2 times 2. Then I have negative plus 3 times x minus 2. And clean it up. 2 times 2, I think, is 4. Negative. I have 1, 2, 3, 4. That's x to the fourth. I have 1, 2, 3, plus 3x to the third, minus 2. And we're all done.
Yes.
Okay? Now, I know some of you might be seeing it going, yeah, if I recognize that 4 can be taken out of all 3 terms, can I just bring that out front and then put whatever's left in the rest? Yeah. But I know that the majority doesn't see that. So it's fine if you can do it. If you can't do it, break it all the way up. All right, are we good with those evens? We're happy?
Wait, I do have a question. At the front and at the back it says negative 2 times 2. Wouldn't that be negative 4?
So notice this. That's a great question. See this negative here? It comes here, and then I have,
The other one is a positive.
and then I have it here. So you see how I put it right here too? Now, I love your thought. Okay, so theoretically, the 100%, if you can get to here, you're getting all the points. In future years, this would actually be the answer. Notice the signs changed because the negative got pulled out. Okay, but I'm not really that worried about it. If you can get to this part right here, cool. If you get to this bottom part, you're ahead of your day, ahead of your time. I like it. On page, which page? 75? Number 4? You got it. All right. Number 4 on page 75. So we have this weird looking object here. This is x squared plus 2x. And then we have this down here, which is 3x minus 1. We have this down here, which is 3x minus 1. And then we have down here is x squared minus 4. So we want to find the perimeter. Okay? So if I find the perimeter, I'm going to take my x squared and x squared. How many x squareds do I have highlighted? 2. So I get 2x squared. And then I take my x's. 3x, 2x, 3x. So 3x plus 2x is 5x. 5x plus 3x is 8x, I believe. And then if I take my numbers, -1, find something else that costs $1, so it's -2. Find something that costs $4, so -2 added to -4 is -6. And that's all it is. Just combining like terms is all you're doing. Anything else? We're good in the hood? Happy? All right, so friends, I'm going to ask you this. We are going to start something. It'll take place over 2 days, but while I'm teaching over the next 2 days, can you refrain from using the restroom during that time? Unless it is a huge emergency that you have to take care of. Please. Pretty please with sugar on top.
How much sugar?
You gonna make it? Any other questions from the homework? Did that answer your question?
Are we starting to move it?
Well, no, we're still in the same chapter. All right. So, my friends, would you find in your notes it's PEF number 9. PEF number 9. 13, 12, number 11. PEF. We're going backwards in time. We are on, looks like page 45. Page 45. All right. So this is going to take 2 days to go through. Okay? I will give you but I just ask that you don't vacate. Who was here? What? You? Yeah. Okay. So, guess you bolted before I got it. All right. So, I am okay. So, the only one where we're going to learn is factoring by grouping. Okay? Yes, there is the logic method. Sometimes it's called the 80-20 or the 90-10 method. They're both good. I'm just going to make sure you have one down. If you can walk out of this class at the end of the year having factoring by grouping down, you're in a really good spot. Okay, so the first thing we're going to do, if I were to multiply these together, I get x times x, which is x squared, x times 2, which is 2x, 8 times x, which is 8x, 8 times 2, which is 16. And then these are like terms. Okay, this is prior knowledge, yes? I hope. Okay, so we have gone from here to here, but now we're going to go from here to here.
Oh, okay.
Okay?
Let's do it.
So we're going to undo these. Good?
Yes.
Page 45. Page 45, sorry. We're going to undo them. Okay? Okay. So I'm going to show you the exact same method. I'm actually going to add a page. And we add just because I want to show this. X squared plus 9x plus 20. Okay, that's the one that we're going to do. So we're basically, our goal is to get this to break down to the two binomials that we would multiply together. Okay? Stop me when you need a question asked. Promise? We're good? All right. The very first thing I'm going to do is take a look at the x squared. If there's not a number sitting there, what number do we know has to always be there?
1.
1. Are we good so far?
Yes.
Anybody stuck? 1x squared and x squared is the exact same thing. It's just we're people, we're lazy, we don't put 1 with the x squareds or 1 with the x. Okay, everyone's good? Yes? All right. Step number 1. Multiply first and last number together.
20x squared.
Okay, I love your thinking, but multiply first and last number.
Oh,
20.
Yeah.
20.
So the first thing is here is I'm going to multiply this, positive 20, and this 1 together. Let me just pause there for a minute. We good so far? You're just putting a 1 in front of the x squared because there's always a 1 in front of a letter, but we just don't write it because we're lazy. Just people are lazy, not you guys. Okay? So does everyone feel comfortable with step 1 that we're going to get 20 times 1, so I'm going to get 20? Okay? So that's first step. Step 2. All whole numbers that multiply to get 20. Okay. What's the most obvious two whole numbers that I could multiply together to get 20? What's the easiest one?
5 and 10.
Go even easier.
1 and 20.
1 and 20. Does everyone agree that 1 times 20 is 20? Okay, is there another set of two whole numbers that I can multiply together to get 20 that you can think of? I heard it over here. 2 and 10. There's one more. 5 and 4. Okay, now let me just pause, stop, regain our thoughts for a second. Does everyone agree that 1 times 20 is 20? Does everyone agree that 2 times 10 is 20? Does everyone agree that 4 times 5 is also 20? Is there any other two whole numbers that I could multiply together to get 20?
20.
Got it up on top. 20 times 1, 1 times 20. Yeah. I could do negatives, but I'm not going to worry about the negatives, but I love your thought right now. Because that's part of the key. That positive 20, I just want positive 20. So theoretically, I could go negative 1 times negative 20 and get positive 20 in any of those as long as they're both negative. I love that thought. Great job. Okay? All right. Is there anything up to this point that you're like, and the reason I'm going in order, it's going to be the exact same thought process every time we do it. Okay? I'm not the mathematician fan of, oh, hey, when it's this, all you have to do is flip it upside down, take the reciprocal, then add 3 to it, and then when you subtract 7, you get the answer, and you're like, but that's only that case? Yeah. Oh, in this next case, we're going to square it first, then we're going to add 4, and then we're going to divide by 19, and if it comes out to an even number, take the square root of it, and if it comes out to an odd number, raise it to the third power, and you're like, how am I going to remember that rule? No, I'm going to show you the same process every time because it works every time. As long as there are two binomials I can multiply together to get it, it will work. Okay? Friends, do you feel comfortable with what we've done so far?
Yes.
Okay? What two factors. And I'm going to call these factors, okay, so we know where to refer to. Factors add up to 9. Hey, where's the 9? Is the 9 part of the problem?
Mhm.
Do you see a 9 up there anywhere?
Yes.
Yeah, this is what we're trying to figure out what's going to add up to. Okay, so we're going to go slow. I know some of you might see it, but if I add 1 and 20 together, what do I get? 21. Is 21 the same number as 9?
No, sir.
Not this week. If I add 2 and 10 together, what do I get? 12. Is 12 the same number as 9 this week?
No.
No. If I add 4 and 5 together, what do I get? 9. Is 9 the same thing as 9? Okay. So I'm just going to circle this. Okay? Use factors with X to fill in. Okay? Ready? See this X squared? I'm just going to keep it as X squared. See this plus 20? I'm just keeping this. I'm going to break this apart now. We said 4 and 5, right?
Yes.
Let me stop there. Morgan, I'm not done teaching though. Dude, hold on. I'm almost done.
Recorded.
You're not going to watch it. Okay, hurry up. Use the bathroom down here, not the one in the East building. 45 minutes later, where'd you go, King Supers? Oh, okay.
Sure, but I don't think you can read signs.
All right. So I'm pausing here for a minute. I mean, by no way, shape, or form am I done with this problem. But let me ask you this, my friends. If I add 4x and 5x together, do I get 9x?
No, you get 9x squared.
If I add 4x and 5x together, I get 9x.
Yeah.
I can only increase my exponent if I'm multiplying.
Oh,
Oh.
damn.
Okay? So notice this. I just separated it. Okay? So, here's a couple things to note. This original thing, x squared plus 9x plus 20, was 3 terms. A term, remember, separated by an addition or subtraction sign. Agree?
Yes.
So this 3-term problem became a how many term problem?
Polynomial?
How many terms?
4.
4. I went from a 3-term, split up the middle, made it a 4-term. Things I want you to notice. 4x plus 5x is 9x. 4 times 5 is 20. So things didn't happen by accident. It didn't happen by this arbitrarily, oh, I'm going to pick 2 fictitious numbers out of the air and hope I'm right. I have a pattern to the madness. Okay, so does everyone feel comfortable? I go from 3 terms here to 4 terms here. I'm on page 45. Page 45. Yeah, I get you guys. All right. So let's just. I'm not done with this problem, but I just want to make sure that we're backfilling a few things. Step 1, we're going to multiply. The very first thing we're going to do is if there's a number sitting here, great. If there's not a number here, I'm going to put a 1. Next, I'm going to multiply the first and last number together. So positive 20 times positive 1, that gives me positive 20. I'm going to write down all the whole numbers that multiply to get us 20. So 1 times 20, 2 times 10, 4 times 5. We're good so far. Yeah.
What are you trying to do? Like, are you simplifying?
I'm trying to get this into the two binomials. What two things did I multiply together to get this? So I'm undoing this.
Okay.
Okay, so basically it's this. So I went from this to this. Now I'm going from this to this. This process, going from here to here is quicker. Going from here to here, we're like reverse engineering the problem. Okay? But I'm going to show you the same exact process. I'm not going to change the stuff tomorrow. I'm not going to, like, 4 days from now, I'm not going to be like, oh, okay, now here's a whole different method. I'm not going to change it, okay? Okay. Watch the language. Okay. So multiply the first and last together. The two whole numbers that would add up to the middle. Okay. And then use the factors with x. So the 4 and the 5, we said, the 4 and the 5 add up to 9. The 4 times 5 gives me 20. And then I'm going to go 4x and 5x. So I went from 3 terms to 4 terms. Good?
Yes.
All right. I'm at 4 terms. Yes? Everyone's good? 4 terms? Happy? Now, hey, disclaimer. I could have had this be 5x. I could have had this be 4x. This order doesn't matter. Okay? I could flip it either way. I had to put it one way or the other. Okay. So now, put your pencils down and just watch. Please. What do I have in common between those green highlighted X? X is the only thing, agree? Okay? Question? No?
Oh, no, yeah.
Okay, that's the green highlighted portion. Agree? Middle sign always comes straight down. All right, let's highlight this. What can I factor out of that pink? Can I factor an X out of both? No, the 20 doesn't have an X. Can I factor a 2 out of both? No, 2 doesn't factor into 5 real nicely. What can I factor out between 5x and 20?
5.
A 5. If I factor a 5 out of 5x, what do I have left? If I factor a 5 out of 5x, what do I have left? If I factor a 5 out of 20, what do I have left? Friends, does it appear I have a red and a black binomial, a 2-item term that's the same? What's the same?
And then you can.
What's the same?
The parentheses.
X plus 4. This is the same, yes? So that comes down here. What do I have left? What do I have left? X plus 5. Friends, the problem's done. Yes, I understand it was a longer, more drawn-out way, but I swear to you there's a method to the madness that's going to help you with this stuff. Okay. So, my friends, we have quite a bit that goes with this. In no way, shape, or form am I done with this lesson. But I would like you, we're out here at 11, right? All I want you to do, I want you to get an honest start on page 49, and I want you to do problem 1 through 3. Friends, that's all I want you to try. You have time right now to try it.
You could take 5 minutes for each question.
You got it.